In this video, we're gonna build Slack bot using AWS Lambda and save data in DynamoDB table. Let me show you a quick demo. Let's go to our Slack channel and say Valley. To do, save the planet. Now, the Slack bot was able to process the message and save the planet in DynamoDB table. Let's take a look. So we have the Lambda, which is triggered by API gateway, and we have the to-dos DynamoDB table. Let me refresh the page and let's go inside the table. And we can see the button view items. And let's see here. So now we have the message, save the planet here. Alright, let's get started. This video will cover the AWS Lambda and how to use the API gateway to trigger the function. We will provide this API endpoint to Slack to get notified of some events, such as posted messages in Slack channel. To protect ourselves, we will use the hash-based message authentication code to compute the signature and verify that the request came from the Slack server and not from someone else. First, you need to create a Slack account. When you have it, go to api.slack.com/apps, click on create an app and choose from scratch. Later on, we will configure our bot and provide the necessary permissions to read and post messages to the Slack channels. You can call your bot whatever you want, but I will name mine Valley and select my workspace. If you scroll down, you will see the app credentials section. We will use the sign-in secret to verify each request that comes from the Slack server manually. Under display information, let's give a short description: compactor robot. To make a bot look good, let's upload an image and update the background color. To get notified of the message posted in the Slack channel or any other event, we will be using the event subscription mechanism. We need to provide an URL endpoint which Slack server will use to post messages. To create this endpoint, we will use the AWS API gateway and Lambda to process those messages. Let's start from scratch and create an AWS IAM user with full access first. Let's go to IAM and create an admin user with programmatic access only and place it in the admin IAM group. Let's click create user and download credentials. Now we can either use them as environment variables or we can generate an AWS profile. To do that, let's run AWS configure and provide the access key and the secret key. It will create a default profile for you. Now, to test that you can access AWS with your admin user, you can run AWS STS get caller identity. You can see the IRN Amazon resource name that points to the admin user. While we're still in IAM section, let's go ahead and create an IAM role and policy for our Lambda. IAM role is IAM identity similar to IAM user, and IAM policy is a set of permissions that determine what the identity can and cannot do in AWS. First, let's create a policy. Instead of selecting from the menu, we can paste the JSON object. The first statement will allow our function to create a log group in the CloudWatch service. Here you need to replace region and account ID to match yours. The second statement will provide access to create log streams and put log events, same with the region and account here. Finally, let's provide full access to the to-dos DynamoDB table that we will create later. Let's give it a name AWS Lambda Slack Access and click Create Policy. Now let's create a role and attach this policy to it. This section will establish trust between certain entities such as a user, EC2 instance, Lambda or any other AWS service. We will select Lambda here, which means only AWS Lambda will be able to use this role. Now you can filter by customer managed policies and select AWS Lambda Slack Access policy. Let's give it a name Valley role and click Create Role. Let me describe the IAM role that we just created to show you some properties. Here is the principal key that determines which entity can use this role. In our case, it is Lambda, as I mentioned before. The next step is to create a simple AWS Lambda that can return the hello world message. Then we gradually improve to process messages and store them in the database. Let's create a Valley folder that will contain our function. Since we're building our Slack bot using Node.js, we need to initialize the project. Let's change the directory to Valley and run npm init. We will use default values except for the entry point. This will produce the package.json file. Later in the lesson we will use it to define function dependencies. Now let's create an app.js with our function. Let's get started with exporting the function. Here you have 3 input arguments. The event represents the Slack post request, which goes through the AWS API gateway enriched with additional properties and headers. The context is a Node.js context, and finally a callback function. It accepts 2 arguments, the error and the response you want to send back to the client. The response object must be compatible with JSON Stringify. In the first iteration, we will simply send hello world JSON object. Let's declare it here and hardcode the message. Let's finish this by calling the callback function. The first argument is null, which means we didn't get any errors processing this request, and the second one is the response. There are a few ways to package our function. We will use the new approach using the Docker image. To do that, let's create a Docker file and define steps to install and expose our function. We will use the public image provided by AWS, which already has Node.js runtime. Then copy all JavaScript files and both package and package log JSON files. If you prefer to copy all the folder content, you can create a Docker ignore file and specify folders and files to ignore during this process, such as node modules. Now let's install dependencies. Later on we will improve this step. Finally, specify the command to start this Docker container. Before we can upload the Docker image, we need to create a private container repository, ECR. Let's call it Valley and keep other default parameters. To learn how to push image to ECR repository, click View Push commands and copy-paste them to the terminal. First of all, you need to authenticate with AWS ECR. Then you need to build the Docker image. Let's use the v0.1.0 tag for our hello world AWS Lambda. Finally, use the Docker push command to upload your function to AWS. When it's finished, you can go to AWS and create a Lambda function. Select container image and give it a Valley name. Find the Docker image with v010 tag and click Select Image. Don't forget to select IAM role that we created earlier, otherwise AWS will create a default role for you without DynamoDB access. Now you have a couple of options to create API gateway. You can either click Add Trigger and select API gateway. This approach is limited in a way how you can configure your API gateway. I always prefer to create gateway separately and attach them to Lambda later. By the way, if you want to learn how to create API gateway and Lambdas using code, check my other video, AWS Serverless Application Model. AWS SAM leverages the CloudFormation template and provide convenient CLI to test, package and upload Lambda functions. Now let's continue and create API gateway from the console. You have a few options here: HTTP API, WebSocket and REST. I will attach a link with a comparison of the different features. In a nutshell, you want to use HTTP API since it's 71% cheaper than REST according to AWS and has all the features that you need at this point. Let's give it a name Slack and create integration with AWS Lambda. Slack will only use post request to send events to us. Let's change any to post. You can separate your Lambda functions using different stages. You can use versions such as v1, v2, v3 or something like staging or production. This name will be appended to the final URL. Verify that you entered everything correctly and press create. Now let's go to Lambda and test our API gateway. Copy the API endpoint URL and use it with curl. Specify that you want a post request. That's the message that we hard-coded in the function. Also, we can go to the CloudWatch and check the Lambda logs there. You have 3 records that indicate one single Lambda function execution: start, end, and report. Let's try to provide our URL for the Slack event subscription. If you enter it right now, you will get an error since Slack wants to verify it. The Slack server will send a special challenge parameter that your API needs to send back to Slack. This will confirm that your endpoint is configured correctly. At this point, you don't even need to use any secrets. Just send whatever Slack sends to you back and you're good. Let me create an event.json file and I'll show you how the request looks like from Slack. Later, we will create a unit test that will use this event as well. There is a lot of stuff that comes from API Gateway. There are some important parameters that we will use. For example, Slack signature header is used to verify that the request came from the Slack and not from anyone else. Also, it verifies the integrity of the data. Here, under the body key, we will extract the challenge and send it back to Slack. Also, type is used to determine what kind of request Slack sent to us. Here is a URL verification. Now let's update our Lambda function to handle verification. First, let's get rid of the hello world message. To get started, we need to parse the body string to the JavaScript object. Then, based on the type of the request, switch and handle them differently. Here is a URL verification type that we saw in the event object. If we get that kind of request, we just use the callback function and send it back to Slack. The first argument is an error, which is null, and the second one challenge string. Default case will simply call callback with null. Later, we will also use sign-in secret to verify that the request came from Slack. Let's go back to the terminal, build a new Docker image with 0.11 version and upload it to AWS. To redeploy the Lambda function, go to the image section, use deploy new image button and select the proper tag. It will take a few seconds to update the function. Now let's try our URL again, click retry. At this time, Slack was able to verify it. It's time to talk about how we can verify Slack requests. We want to be confident that those post requests came from the Slack server and not from someone else. Slack uses something called hash-based message authentication code. It's a special type of message authentication code MAC involving a cryptographic hash function and a secret cryptographic key. It is used to verify both the data integrity and authenticity of the message. Slack creates a unique string for your app and share it with you. We just need to verify signature using our sign-in secret. On each HTTP request that Slack sends, they add the X-Slack signature HTTP header. The signature is created by combining the sign-in secret with the body of the request they are sending using a standard HMAC SHA-256 keyed hash. The resulting signature is unique to each request and doesn't directly contain any secret information. That keeps your app secure, preventing bad actors from causing damage. Sign-in secrets replace the old verification tokens. We're going to follow this logic. Our app receives a request from Slack. Our app computes a signature based on the request. Compare the signature we have computed with the signature on the request. First, let's try it out on the event that we created earlier. This is optional, you don't need to follow. Let's create a verify.js file. To use this hash function, import the crypto standard node module. Then we need a sign-in secret. This comes from your Slack bot page under basic information. The sign-in secret that I used in the code came from the previous Slack bot that I created. This secret we will use in our Lambda. The next step is to create base string. It has to follow a special pattern. First, you would always use a version equal to 0. Then you separate it using a colon. The next argument is a timestamp of the request. You can take it from the Slack request timestamp header. Finally, you take the body of the request and append it to the string. Now we can compute the signature using the crypto package. Use sign-in secret as a key and update method on base string. Let's print out the result at the end. Let's run node verify.js, copy the hash and compare with the Slack signature. We can see that the signature matches. We just need to add v0 version in our final code. Now please do me a favor and like this video. It really helps with the YouTube search and motivates me to keep creating these videos. At this point we can implement the verification method in our Lambda. Let's create a security.js file and start with importing the crypto package. Let's export this function and accept two arguments: raw event from the Slack server and sign-in secret. First, let's extract the body payload. Since HTTP headers case insensitive, Slack can send you both versions, lowercase and uppercase. We need to convert them to lowercase before accessing the key of the JavaScript object. Create a helper method makeLower. Now we can safely access Slack request timestamp and Slack signature. Let's create a base string similar to our example. Take the v0 version, combine it with the timestamp and request body. Compute the hash. Prepend the v0 version and finally compare the computed signature with the one Slack sent to us and return the result. Now we can import this function and use it to verify each Slack request. In this video I decided to use environment variables to pass secrets. If you're building a production grade system, you probably want to use Secrets Manager. I will create a video soon explaining the AWS Lambda Secrets Manager integration and put it in the description. Now let's add if-else statement. If the request is valid, then process it. Otherwise, ignore it and send an error back. We need to add the Slack sign-in secret to Lambda. Under the Configuration tab, you can find environment variables. Add the key and the value from the Slack page. We can optionally create a unit test for our function. Nothing special about it. Import security and event. Parse signature from the event and validate it. To run the test, we need to install Jest as a development dependency. In the package.json, update the test command. Go to the terminal and run npm test. Alright, our validate Slack request unit test passed. Now let's go back to Slack. We can either use a public or private channel to test a bot. Based on the selection, you would need to update permissions and event types. Let's create a private Slack channel called Earth. To get notified if something happens in the Slack channel, we need to enable events and paste our URL. We can choose what kind of event we want to receive. Under Subscribe to Bot Events, click on Add Bot User Event. We're going to start with plain messages. To receive messages from the private channel, you need to add message groups. If you want to receive messages from the public channels, you need to add message channels. By the way, this keyword message is an exact event type that you receive from Slack. We will use a switch statement to process those requests differently. Click Save and Slack automatically added bot permissions to read those messages. Let's check them out. Go to Auth and Permissions. Under the scopes, you see that we now have channels and groups scopes. Optionally, you can toggle the switch to show that your bot is always online. Now let's go back to app.js and add functionality to print those messages from the Slack channel. It's going to be event callback type. We will use the process request method that we define next. It accepts a body and a callback function. Based on the type of the request, we switch. To process a message, let's create a new method process messages and add a default callback with a null error. Now the process messages function. It will accept the same parameters, body and a callback. We simply print out the message to the console. In our case, it will be a CloudWatch log. You can use different methods, debug, log, error, etc. In the end, let's use a callback as well to indicate that we finished. Now we can improve the Docker file. Instead of npm install that uses the package.json with our dependencies, we will use the npm CI production. CI will use a package log file instead with not only dependencies that we install directly, but also dependencies of dependencies that make your build more reliable since you specify all possible versions. Production flag is used to only install regular dependencies. For example, it will ignore the Jest testing framework. At this point we don't have any dependencies, but we will install them later on. Since we updated the function, we need to rebuild the Docker image, push it to the ECR repository and redeploy the Lambda function with a new tag. You can also delete all the logs. It's going to be easier to find our messages from the Slack. Before we can type anything in the channel, we need to install the Slack bot to the workspace. First of all, you need to invite your app to the channel. Then just type something, for example, hello. To see the message hello, let's go to the CloudWatch log. Here we have a message that the bot was invited. In another log, you can see the hello message. Next, we want to be able to save something to the DynamoDB table. Let's go ahead and create a to-dos table for the Valley. Let's use UUID for the partition key. UUID is a globally unique identifier for our records. Your table name must match with the name you specified in the IAM policy. Otherwise, you will get access denied. Now let's update the events. We want to run Lambda not on every message, but only when our bot is mentioned by name. Instead of message channels and message groups, add app mention and click save. Since this event added additional permissions for Slack bot, you need to reinstall it. Before you do that, let's update scopes to be able to write messages to Slack as a bot. Let's remove channels and groups from here as well and add chat to write. Now we can reinstall it. Let's make some modifications to our code to handle the new event. First, we will need these dependencies: AWS SDK to save data in the DynamoDB table, UUID to generate random global unique IDs, and Axios to post messages to the Slack. Create a new db.js file for DynamoDB. First, import the AWS SDK and UUID. Then you need to set the region where you created a table. In my case, it's a US East 1, which is one of the cheapest and largest regions that AWS has. Then initialize the DynamoDB instance and create a save item method. It will accept the item, which is a text that you want to save in database, and a callback function to indicate that it was successful or not. Then you need to define the structure of the record. UUID is our partition key of type string and the text of type string as well. Call the put item method on the DB instance. If there is an error, return it, otherwise return nothing. Let's go back to the app.js and add an additional case to the switch method to handle app mention request types. Let's import Axios and DB. You would also need additional secret from the Slack to be able to post messages, which is called bot token. Let's add this environment variable right away. You can find the bot token under bot user auth token. It must start with XOXB. Now let's implement the process app mention method. First, let's get the text that we want to save. It will simply split the string using a colon and take the last item in the array. Then let's call the save item method and create a message that we will send to Slack. Let's get the Slack channel ID from the body and construct the message. Finally, let's use Axios to create post request. It must be the post method, then the static URL to send this request and mandatory headers. Let's specify the content type of the message to application JSON. Also specify the char set to get rid of the warning. To authenticate with Slack, you also need to send authorization header with a bot token. Code is available in the GitHub repository. At this point you know the drill: build, push and redeploy the Lambda. You can also just use the latest tag. Every time you push it, AWS will remove the latest tag from the old image and assign it to the new one you uploaded last. Alright, we're ready for the final test. In our private Earth Slack channel, let's say Wally to do save the planet. Our app was notified of that event. It saved the item in the database and posted a Slack message to the channel. Let's check it in DynamoDB table if we have a record. You can click on view items to get the data. We can see that we got the record save the planet with random UID generated for us. Take a note that this function is not idempotent, which means in case of the error and retry, you get the multiple database records and identical Slack messages. It's your responsibility to make sure your code is idempotent. I will attach a link from AWS with some suggestions. Thank you for watching, don't forget to help me with a like, and I'll see you in the next video.